Hello guys, we're doing some review for test number 4 today. Got a little music going in the background because I'm sitting outside on my back patio. And hopefully you are someplace comfortable and safe so we can do some algebra review together. So I'm just going to go through these questions. You can watch, skip, fast forward, pause as much or as often as you need. Take notes on this because you can have the notes and access the notes and use the notes when you take the test number 4, and it'll help you get through it and pass and do well. To show me that you have the knowledge and you can express the knowledge and convey the correct knowledge back to me in test 4, and things will all be good. So first thing, when you write a given equation in standard form, what we're supposed to remember is that standard form has the highest exponent first, so the x squared has to come first. Then the regular x comes second, and then the piece with no x comes third. Standard form means the highest exponents go from left to right and they count down. So the exponent of 2 is the highest, then technically this x has an exponent of 1, and then technically this c has an x with an exponent of 0, but anything to the 0 power is 1. 1 times c is just c, don't need to write it, and then anything with an exponent of 1 also doesn't need to be written. So that's standard form. So in order to get this into standard form, I'm going to add the 7 away from the y, and then I have the x squared term is supposed to go first. This 3x here is a positive 3x because there's no negative in front of it, so that means it's positive. And the plus 7 goes at the end, and then y is already by itself. That is standard form. So that's all we have to do is rearrange it. Question number 2. We're going to match the equation with the correct graph. You can go to your calculator, go to the y equals, and graph each one of these equations one at a time and match up which picture it goes with. But we could also hopefully remember some of the things that the videos taught us about the equations and which way our graphs face. What I mean by that is a parabola that's a smiley face, a U-shape, facing up, has to have a positive x squared term. All parabolas, the curves, the U-shapes or the N-shapes, those are parabolas, those come from quadratic equations, equations with exponents of 2. If it's a positive x squared, that means it's a smiley face. So this one is y equals x squared minus 8x plus 12. Like somebody with a smiley face, that's a happy parabola because it's a positive x squared. An unhappy parabola, boo-hoo-hoo, with a frowny face, would have a negative attitude or a negative x squared. So that's how we can tell the difference without even having to go to the calculator. Now the other two are exponential graphs. So how do we know which one's going up from left to right and which one's going down? I know looking at the graphs, this one is a growth because it's going up from left to right. This one is a decay because it's going down from left to right. So how do we tell with the equations which one's going up and which one's going down? Well, the growth going up has to be increasing by a number bigger than 1. So when you look at the equations, you want the one that has a number greater than 1 connected to the x. The 2 has the exponent of x. That 2 means I'm multiplying times 2 times 2 times 2 from one y value to the next y value. So if you look at the points, 0, 1, 1, 2, 2, 4, 3, 8, look at the y values. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2, the next one would be 16. So that's increasing because they're being multiplied times 2. That leaves our last one to be a decay because it's decreasing. Basically, you're multiplying by a fraction or dividing. So if you look at the y values, they go from 3 to 1 to 1/3 to 1/9. So this one is decreasing by dividing by 3. And dividing by 3 would be the same thing as multiplying times a third. So the y value of 3 times 1/3 is 1, times 1/3 is 1/3, times 1/3 is 1/9. So that is a decay because our b value, the number attached to the exponent, is a value smaller than 1, so it goes down. All right, number 3. Given a function, 2x squared plus 12, find f of -2. This simply means plug in -2 where the x was, and then go to your calculator or do it by hand. So -2 squared means -2 times -2, which is +4. 2 times 4 is 8, and then 8 plus 12 is 20. And you could do that on your calculator as well, whatever is easier for you or whatever you have access to. Number 4, finding the formula for finding the axis of symmetry of a parabola is x equals -b over 2a. This is a formula that you are expected to be able to recognize and use. And remember from the standard form equation I wrote on the other page, a is the number next to the x squared, b is the number next to the x, and then c is the third number there. So our a value for this particular question is a 1, because it's 1x squared. Our b value is the 6, and c is the subtract 40, which makes it a -40. So let's plug the numbers into where they are supposed to go. X equals -b over 2a, which turns into -6 divided by 2. So our equation for the axis of symmetry is x equals -3. Now, just a refresher, when you're looking at a graph, the axis of symmetry is the line that splits the parabola right down the middle, so it could be folded in half. It is always an x equals equation. Always, always, always. So where the line intersects the parabola is our vertex. And that's what we want to find for the next question. Find the coordinates of the vertex. Well, we already know the x-coordinate because it's the same x value as the axis of symmetry. So what we're going to do is take our equation, find the y value using the x value that matches our axis of symmetry. So that means we're going to plug in -3 for all the x's, and then just figure out what is the y value that goes with it. All right, so 9 minus 18 is -9. -9 minus 40 more, -49. That's the y-coordinate that goes with the x value we found in part A, and that's our vertex. Same x value as the axis of symmetry, and the y value comes from plugging that in for x into the equation. Now remember, this is review for your test, so if you have these notes written down, when you come to a question similar to this on the test, you'll have a reference of what to look at and what to study or practice. Okay, next one. The following is a geometric sequence because the numbers are changing by multiplication or division. Determine the common ratio and then find the 7th term. The common ratio means, hey, how is this list changing? What's the number that's being used to multiply over and over and over? So if you look at -1/3, and then it goes to 1, then to -3, then to +9, then to -27, it's alternating back and forth. That means we're multiplying by a negative number. And so if we look at the fact that we're going from 1, 3, 9, 27, how do we get from 1 to 3, 3 to 9, 9 to 27 using multiplication? Well, we're multiplying by -3 over and over and over. So if we go to our calculator or continue in our list, this is term number 1, the 1 is term number 2, the -3 is term number 3, the 9 is term number 4, the -27 is term number 5, times 3 would be 81 for term number 6, and term number 7, I think, is 243. But it would be negatives, but I'm going to go to my calculator and double check that. So I want to do 81 times negative 3. There we go, negative 243. Bingo is our 7th term. Number 6. This sequence is arithmetic because it's using addition. So geometric is when the numbers are increased by multiplying or dividing. And arithmetic, like arithmetic, is when the numbers are increasing by adding or subtracting. So the common difference is what number is being added over and over and over to get this list of values. So if we look at these, negative 12 to negative 5 to 2 to 9 to 16, the easiest place to look to see where or how these numbers are changing is probably some of the smaller numbers that are positive. So how do we get from 2 to 9 and then from 9 to 16? Well, we do that by adding 7. So let's just keep adding 7. The negative 12 is term number 1, and then the negative 5 is term number 2, and then the 2 is the 3rd term, the 9 is the 4th term, the 16 is the 5th term, 16 plus 7 is 23, that's the 6th term, and 23 plus 7 is 30 for our 7th term. Alright, now let's do some picking out of stuff from a parabola. Here's a nice graph of a parabola. Write the equation of the axis of symmetry. The axis of symmetry equation is always x equals. And we just need to figure out where is the line that would fold this graph in half, and what's the x value for where that line falls. And that is at x equals 2. What are the coordinates of the vertex? Well, I'm glad you asked. The coordinates of the vertex, that's where the axis of symmetry meets the parabola. It's the turning point of the graph. And that is at the point 2, looks like negative 1. Alright, state the roots, or sometimes called the zeros. The roots for the zeros are where the graph crosses the x-intercept, or x-axis. So, where does our graph cross the x-axis? We have a root here at 1, and a root here at 3. So, sometimes you'll see them written in set notation. And those are our roots, the x-intercepts. Explain whether the graph, the vertex, is a maximum or a minimum. We have not talked about that yet today, so let's do it now. Simply put, is this vertex the highest point on the graph or the lowest point? Well, our graph comes down like a fishbowl or a smiley face, and that vertex is the lowest point that it reaches, so it is a minimum. How would you tell from this equation? You would tell from the equation because the equation would have a positive a value in front of the x squared. When a is positive, our parabola is happy, so it makes a smiley face. Alright, so it's the lowest point on the graph, and we would tell that from the equation because the a value, the number in front of the x squared, if the x squared is positive, it's a smiley face opening up. Page 3, cruising right along. Alright, which of the following quadratic equations have a vertex that is a maximum or a minimum? So, based on what I just talked about, looking at the very first equation we have here, is the x squared positive or negative? X squared is positive. That means our graph will open upwards, and the vertex is a minimum. Next one. X squared is negative, so it's a frowny face. Oh, poor sad parabola. That means the vertex is a maximum. And then the third one. X squared is positive, so it's happy. So our parabola opens upward, and the vertex is a minimum. All right, reviewing back from the first page, when we were matching equations to graph, talked about exponential growth versus exponential decay. Which is which? Growth is going to get larger, go up from left to right. Decay will get smaller and go down from left to right. So that means that this first one, going down our page from left to right, is an exponential decay. And our second one, going up from left to right, is an exponential growth. Now both of these equations would fit the format A times B to the x. When you see this equation, you're supposed to know that A is the starting value, or on the graph it's the y-intercept. The B is the change value, or the number that's used to multiply from one point to the next point. It's the pattern. This number tells you the pattern of how the y values change. All right? So, building off of that decay and growth, which one of these equations is a decay? Well, we tell our decay and growth equations based on the number connected to x. In this case, the 1/3 is in the parentheses connected to the x, so that means that in the table of values, we would multiply by 1/3 over and over and over. The table would start with a 6, a y value of 6. That would be the y-intercept. But the table would start when x is 0, y is 6, and then we would multiply 1/3 to get from one value to the next. You could do this on your calculator, but the 6 is the value of y when x is 0, the y-intercept. And then we would multiply times 1/3. 6 times 1/3 would be the same thing as saying 6 divided by 3. And then we would do it again. 2 times 1/3 would make it 2/3. We just keep multiplying times 1/3. So the numbers are getting smaller, means this one is a decay. And then if the number in the parentheses is larger than 1, that's going to be a growth. What that number in the parentheses being a 3, what that is telling us is with our y-intercept at 6, we would multiply times 3 from one y value to the next y value, and so on and so forth. All right, so that's how we tell whether it's a growth or a decay from an equation. Number 13. Did you know that rumors spread exponentially, almost like the coronavirus? A rumor about Mr. Stewart was started by some students and spreads according to the equation r of x equals 3, parentheses, 6 to the x. How many students initially started the rumor? So based on what I explained up here, the number that you look for the starting amount is the number in front of the parentheses, the number that would show us the y-intercept. That's the starting amount. The number in the parentheses attached to the exponent of x is how many new people find out each day. So the starting amount of people for our rumor is 3. So 3 students got together and started a rumor about Mr. Stewart. Not very nice, unless it's a good rumor, in which case, thank you. All right, number 14. Given the equation y equals 5 times 2 to the x, what's the initial value, or the y-intercept? What's the change value, or the common ratio? Well, we just talked about this. So our initial value is the first number, 5. So 5 items to start with, and the 2 is the change value, which means it doubles each time. If we had a table or had to graph it, we could start off with 0, 5, that's the y-intercept, and then times 2, times 2, times 2, times 2, and just keep going. That's what the change value does. It shows me the pattern how the y values are multiplying times 2. So based on that, let's write an equation for number 15. Write the equation of the given exponential graph. Let's look at how the y values change. The y values change from 1.5 to 3 to 6 to 12. It seems as though they are being multiplied times 2. So our change value, the b value, when we write an exponential equation and use the format a times b to the x, the b is our change value, and we just noticed based on the points that were given, the b values are changing by multiplying times 2. The a is the y-intercept. So where is our y-intercept? Where is that y-intercept? Where are you, you bugger? Here you are, Mr. Y-intercept, or Miss Y-intercept, or Mrs. Y-intercept. I don't know. I haven't officially met them. So the y-intercept has an a value of 3. So let's put those two numbers in the right place into the format of an equation. Y-intercept is 3, change value is 2, make the x an exponent, and bam, we have our equation. Woo! Doing good stuff. Good job. All right, number 16. We're going to graph a parabola. If you don't have access to a graphing calculator, you can try to find one online, either using Desmos.com. They have a graphing calculator you can use. You could also get a graphing calculator app for your phone. I know those exist. You could probably just Google free graphing calculator. Or you could even Google the graph of this equation and see what happens there. Let's say you do have a calculator, in which case we go to y equals, and I'll just type in the equation, which was x squared minus 6x plus 8. X squared minus 6x plus 8. And then I just graphic gives me an idea of the picture, but what I really want is second table, get the table of values, because this is going to give me some better points that I can accurately put onto my paper. So on this table, the vertex and the axis of symmetry are the points in the middle. Now what I mean by middle is you have to look at the y values and the pattern that you see. See how the numbers are counting down. 35, 24, 15, 8, 3, 0, negative 1. Then they start counting up using the same numbers. So the middle is our vertex, and the x value of that vertex is the axis of symmetry. So if I were to ask you what's the axis of symmetry, you would find this middle point here in the y column. The axis of symmetry is the x. X equals 3. The vertex is the whole point, 3, negative 1. But what I want to do is graph it. So, at the point 0, 8, 1, 3, 2, 0. So let's plot those points. What's the next point? 0, 8, 1, 3, 2, 0. 3, negative 1. That's the vertex. Now remember, when we did parabola graphs, they are symmetric. They can be folded in half. So now these points counting up the other direction will be at the same y value. So I can go 1 square to the right and then up to match the height of the other dot. Then 1 square to the right and up to match the height of the other dot. So when I graph it, get a nice smooth picture. Or try to anyways, and there's our parabola. Now the reason why I had you do this is so you can practice getting the picture of the graph on the calculator, because on your test I'll give you an equation and ask you which picture matches the equation. So you're going to have to be able to somehow get a graph or a picture of the given equation and match it to the 4 choices. And the last one. A particular chemical substance has a half-life of 6 months. Now remember, 6 months is half of the year. If there is 800 milligrams of this substance initially, to start with, how much remains after 4 years? 4 years would be 8 half years. So we're going to have to use the 8 as the exponent. So we are going to take the equation y equals 800. Half of it is left after every half of year. But we want to do 4 years, which is 8 half a years. That means we use an exponent of 8. So we're going to go to the calculator and do 800 times 0.5 with an exponent of 8. You can use 1/2 instead of 0.5. That's fine. So 3.125 is the answer. If you have an Inspire, we can do the same thing. 800 times 1/2 with an exponent of x. Oh, we want an exponent of 8. Silly me. That's the equation. We want to evaluate the equation with an exponent of 8. There we go. So when the Inspire gives you the fraction, if you need the decimal version, then when you do your calculation, hit Control, then Enter, and you see the squiggly equal sign above it, it'll give you the decimal approximation, which matches the other answer. So 3.125 is our answer, and we are done in 27 minutes. 27 minutes and change. Alright, so have a wonderful day. Keep these close to your heart as you take test number 4. Do well, kick butt, and take care. See you later.